So in the last lecture, we calculated a formula for the present value of an income stream. And in this lecture, we're going to kind of answer the obvious next question is, well, if we can calculate a formula for the present value, can we also calculate a formula for the future value? Right, and to do this, we're going to make all the same assumptions that we did with the previous example. Right, we're going to assume that we have an income stream whose rate is described by this function p of t. So this is the rate of income. And we're going to assume we're looking at this over a relatively short period of time, right? Delta t, that's going to be a time interval, a small time interval. And we're going to assume that we're getting some kind of an interest rate R on the investment. Okay, so over a small time interval, delta t, the amount earned is the deposit rate times the time. So far, this is the same as it was in our present value calculation. This is P of t, delta t. Okay, so what is the future value of this particular little slice of income? Right. Well, here's where it gets a little different. Right now, the amount, excuse me, it's not the amount, or the future value is P of t, delta t, e to the r. Now here's where we have to stop and think for a second. Okay. Our starting point for this little time slice is t, right? And I'm going to say let m be the length of the investment. Okay, so if we're starting at time t and we're going to let it sit out to time m, then the time value here is going to be m minus t. Right now it's going to flow just like, again, just like we did the last time. The total future value is the sum of all these individual future values. And again, I'm going to rearrange this to put the delta t at the end, just because that's kind of customary. Then I will take the limit as delta t, that's a delta, as delta t goes to 0. And just we saw for back in first semester calculus, right, the limit of this sum is what we call an integral. So the future value is the integral from 0 to m p of t e to the r m minus t dt. Now sometimes some textbooks will stop here. We actually can clean this up a little bit further. If I make this the integral from 0 to m p of t, oops, not p of t times e to the rm times e to the negative rt dt. Right? I just distributed the r into the parentheses, then applied some exponent rules to split that up. Now, that e to the rm part, there's no t in there, right? With respect to t, that's a constant. So I can pull that out in front and make this e to the rm integral 0 to m p of t e to the negative rt dt. And that's kind of my preferred version of the formula. That's the one I'll usually use. So I've summarized that here, right? Clean it up so we've got a nice, neat version to look at. And again, just to be clear what we've derived here, right? This is a formula for the future value of an income stream represented by P of T over a period of M years, earning an interest rate, that's the R. Okay, so now that we have these formulas in hand, in the next lecture, we're going to look at some examples and see how you can actually apply this to some practical situations.